Glassware safety. Glassware is an amazing tool in a laboratory. It is capable of sustaining high and low temperatures, can be opaque or transparent in nature, and the materials to make it are in high supply. However, it still can be quite fragile, especially under certain laboratory circumstances. Combined with the potentially dangerous chemicals being mixed in lab glassware, this can lead to some dangerous situations. Glassware is designed for a specific purpose. It should only be used for that purpose. Makeshift apparatus may be unstable and could lead to accidents and injuries. Selecting glassware. When selecting glassware, determine the compatibility of the glassware with the chemicals or the process. Some chemicals react with glass or cause damage, etch glass. If your process involves temperature or pressure changes, ensure the glassware can withstand the changes. Examples: before working with glassware, always inspect it for flaws. If defects are discovered, the glass should be removed from service. Never carry a flask by its neck or a beaker by its side. Always use two hands carrying any glassware. Position one hand under the glass for support. Appropriate gloves should be worn when there is a risk of breakage. Example: inserting a glass rod. Chemical contamination or thermal hazard. When handling hot or cold glassware, always wear insulated gloves. Avoid physical stresses to the glassware. Where necessary, stabilize it by using clamps and platforms to relieve pressure. Never heat or cool glassware unless it is designed for those processes. Round bottom flasks are best for boiling liquids. Never set hot glass on a cold bench top. When storing glassware, remember to keep it away from shelf edges. Place glassware toward the back of benches or hoods. Remember, fume hoods and biosafety cabinets should not be used for storage. Don't let instruments roll around in drawers. Use drawer pads or slip-proof material. Vacuum and pressure operations. Vacuum or pressure operations can severely test glassware. Container walls must be able to withstand pressure differences. If the container is not strong enough, the container may implode. Round-bottomed or thick-walled flasks must always be used. Glassware designed for vacuum or pressure operations is rated for specific pressure limits. Glassware that has been repaired or shows signs of defect, flaw, or damage cannot be used in a vacuum system. When setting up a vacuum system, protective measures must be taken. Place all vacuum apparatus behind a blast shield or inside a fume hood. Remember to lower the sash of the fume hood. Always wear appropriate protective equipment, safety goggles, face shield, and gloves. Use PVC coated glassware whenever possible. If not available, cover flasks, drawers, and desiccators with tape or mesh. Heating and cooling glassware. Check with the glassware manufacturer to determine safe temperature usage. Most glassware can only be exposed to certain high and low temperatures. Usage outside of those ranges may cause damage or breakage to the glassware. Do not put hot glassware on cold or wet surfaces as it may break with temperature change. Never heat glassware that is etched, cracked, chipped, nicked, or scratched. Glassware with thick walls, example, bottles and jars, should never be heated over a direct flame. Additionally, do not heat glassware directly on electrical heating elements. Do not look down into a vessel being heated. Cool all glassware slowly to prevent breakage unless using specifically designed glassware. Use care when removing glassware from ultra low temperature freezers, -70 to -150 degrees Celsius, to prevent thermal shock and cracking. For best results, immediately rinse the entire bottle under cold running water until thawing begins. Never place bottles directly from the freezer into warm water baths. When using a Bunsen burner, the flame should touch the glass below the liquid level. A ceramic centered wire gauze will diffuse the burner flame to provide more even heat. Always use hot plates that are larger than the bottom of the vessel being heated. Thick walled glassware, example, jars, bottles, cylinders, and filter flasks, should never be heated on hot plates.
Cleaning and drying glassware.
Good lab technique necessitates the use of clean glassware. Glass must be physically clean, chemically clean, and in many cases sterile. Many glassware accidents occur during cleaning. Some reminders when washing and drying glassware are: eye protection and heavy duty slip resistant and chemically resistant gloves should be worn when washing glassware. Wash glassware as quickly as possible after use. The longer it is left unwashed, the harder it will be to clean. If necessary, allow harder to clean apparatus to soak in soapy water. Do not overload sinks or soaking bins. Keep glassware clear of the sides of the sink. Rubber mats can also help reduce the risk of breakage and injury. Never use worn out cleaning brushes, they can scratch or abrade the glass. Specialized training in the safe usage of caustic cleaning agents must be completed before using aqua regia, chromic acid, or other reactive solutions to clean glassware. When drying glassware, place articles on towels, lined basket, or slip resistant pad. Be sure to place away from the edge of the bench. Large containers may be hung on pegs to dry. When cleaning pipettes, place pipettes tips down into a cylinder or tall jar of water or appropriate disinfectant. Example, for biologically contaminated tips. A pad of cotton or glass wool at the bottom will help prevent breakage of the tips. Ensure the water or the disinfectant level is high enough to immerse the pipettes. New glassware should be washed before use to remove any residue or loose particles. Disposal and spill cleanup. Broken glass. Glass is fragile and breaks easily. When the glass breaks, care should be taken to reduce the risk of cuts. If something is falling, let it drop. Catching it may cause the glassware to break in your hand. Wear cut-resistant gloves when handling broken glass. Disposal nitrile or latex gloves should never be worn. Glass will cut through those gloves. When cleaning broken glass, use mechanical means to pick up the pieces. Tongs, tweezers or forceps should be used to pick up large pieces of broken glass. Small shards can be picked up using a wet paper towel or absorbent pad or by using rolled up tape. Proper disposal ensures that others aren't injured by improperly disposed of broken glass. Contaminated broken glass. Place in rigid puncture resistant container, example Sharps container, as per CPCB and local regulations. For chemically contaminated broken glass, closed and sealed containers should be tagged as chemical waste. Uncontaminated broken glass. The uncontaminated broken glass may be disposed of in a broken glass box or uncontaminated waste box. Hazards. Cuts from the damaged or broken glass. Cuts from flying glass due to implosion following evacuation or mechanical shock or stress. Cuts from forcing plastic tubing, teats, or rubber bunks onto glass tubing, pipettes, or condensers that break. Cuts from broken glass and sharp items. Example, pasture pipettes disposed in ordinary waste bins. Burns from the heated glass. Poisoning following the cuts by contaminated glassware.